til en original
podcast fra Arrow. Velkommen til Innovators Club. Rigtig god fornøjelse.
Well, hello everyone, and welcome to this podcast on AI and machine learning, a follow-up podcast on the conference that we just went to, Applied AI Nordics in Planetarium. So my name is Martin Fischer, and I am responsible for our ISV program that we call Innovation Factory. Today I have two of my colleagues, Sara and Søren, and I will say ladies first, an introduction to you, Sara.
Thank you. So my name is Sara, and I work at Arrow Sweden, if you didn't notice by my dialect. And I work in a group called the Technical Solutions Group, and my focus areas are machine learning and AI, because I have a background as a data scientist.
And we're going to hear a lot more about that later in the podcast. Søren?
And I'm Søren Leisen. I work with Arrow as a business developer, and I hold responsibility for the collaboration with NVIDIA.
Thank you. So, a follow-up on the Applied AI Nordics. What is your thoughts?
Yeah, so this conference was, first reaction, it was very cool. So we were there for 2 days, and we're inside this really cool planetarium, which I like, because I like space. I'm a fan of space. We're in it right now, actually. And there were a lot of really nice sessions, and I was really impressed because everybody who came, like the guests, and they were all super curious about machine learning and AI. So I was thinking about that when I was standing at the booth. Like when the sessions were on, there was no people out in the hallways. They were all cramped in some kind of session, and the general atmosphere was really cozy because people were there and they were like, "Yeah, I'm not 100% sure what AI and machine learning is, but I'm just here to learn." So they would just go into every session.
Exactly.
Which is this really nice, cozy, amazing atmosphere of people just being ready to absorb as much information as possible. And it kind of reminds me of the early days when I did a lot of science conferences when I was still in academia. And also looking back at 2 or 3 years ago in Sweden, when we started doing these AI conferences, that people were also genuinely curious but not sure what it meant. So I liked it.
Yeah, so do I. Søren, any thoughts on the conference?
Some of the same observations. I think also the audience is a bit different than we see in traditional conference of infrastructure, data center. I noticed the audience is younger, and also the split between women and men. There's a lot more women into AI, which struck me, and I also noticed the curiosity, and I spoke to some customers which also took back and said, I get inspiration, and how do I go back and try to apply some of these ideas into the bigger organization I work for, which is, I think, back to the early stages. So the project might not be there yet, but they're out looking and they need inspiration to where to start.
Yeah. It was definitely amazing, and I also think about that you just said, that the split and the age. So it was a very diverse crowd, and I like that as well. So I think this was the first time they actually held this Applied AI.
It's the second one. Today arranged one last year, and this was the second run.
Yeah. So just for having them the second time, it was really well arranged. It was really nice put, and my only regret was that I should have brought some more interactive demos or something. Mm-hmm. So maybe that's what I would do different next year, to actually bring prepared applications they can directly interact with, just for fun.
Yeah, because a lot of the whole, we saw some exhibitor had some mid-bot journey integrated to an application that could change the real world into a Pixar-inspired world. And at our booth, we had AI in the pockets to do some. It was a hardware piece where you can plug an external device to your laptop, so you can do live rendering or animations or anything like that, object detection or whatever it could be. So there's a lot of seeing is believing in this game to understand, because AI and ML is super complex, and you know a lot about that, Sarah.
Yes.
So it is to start with the business case, the use case, and look into what can the business outcome be instead of just panicking. So, yeah.
I think also from an Arrow perspective, because Arrow is more than distribution. Arrow is solutions. Arrow is
exactly
IoT. So that was also a learning and also in dialogue with customers. Customers are looking for somebody that can sort of collect the full project or help them scope the full project, because the project is about what you want to achieve, but it's also about, that can be a software piece, that can be a scientist piece, that can be a hardware piece, and how do you connect the dots?
Exactly.
And I think that's something that customers are also looking into, because this project maybe opens in one part of the business, but how do you speak to other departments and back to the hardware and the acceleration and so forth.
Yeah, for sure. And like when people are looking for a solution, they might not even know that they're actually looking for one. They just might have an idea, and then actually being able to help someone get what they need throughout the full stack, not only software but also hardware and integration, and just thinking about the day-to-day work, like what are the departments who need access to this, how will we integrate it, how will they share resources. All of those things can quickly become quite complex, and then they might not know how to do this, or maybe they don't even want to think about it, and then we're like, okay, but we can package something for you that we know will work.
Yeah, so we can guide them and navigate them in the full stack, so to say, from the microcontroller to the finished software application layer. And
yes.
And Sarah, you definitely had a story to tell. Yeah,
exactly. So that's basically what my talk was about, because my background is actually in biomedicine and toxicology. So I worked in the Karolinska Medical University and was doing a lot of research and then started going into machine learning from the classical statistics. And what happened was that all the workplaces up until Arrow, because they were research labs or medtech companies, they didn't have nowhere near maybe like a platform or an integrated solution that would supply both hardware and software for the data scientists to do their job. So basically we were self-managed, and definitely shadow IT, because we all had our own bare metal server under our desk, because that's just how we worked. And the deal was between IT and us that we do not mess with each other's stuff. Basically, it was like an oral gentleman's agreement. Like you don't look at mine and I don't look at yours. And just being self-managed. And but doing that also meant that even though failing a lot of times on the way and doing stupid stuff, I gained a lot of knowledge, but it came at the cost of Sarah is not doing the machine learning right now. Sarah has to update the operative system, or Sarah has to fix why this thing is not working, or Sarah has to blah, blah, blah. And it's fun, but also frustrating, but it means the development time and the ramp up time is taking too long. And that's basically what a lot of the available platforms do today. They're just adding abstraction layers. So I get exactly what I need without having to care about the underlying infrastructure, which is kind of nice. But going there, it just meant, when I had a presentation, I was telling them about the story when I was working at a governmental agency. We were doing genomics. It just means that we were sequencing the genomes of virus and bacteria, just finding out what sequence of letters their genome was, and finding out which one it belonged to. And this is just a data analysis when the lab work was finished. And we all had our own bare metal server, and we were 4 people in the same room. It was a database guy, and then it was me, and then there were the 2 other bioinformaticians. So at that time, I would be maybe a junior bioinformatician or something, and they were maybe a senior. And all the pipelines and everything we had were in-house built and with open source. And the database was basically just folders on the intranet. So with all the sequence letters that belong to the bacteria or virus. And when we were doing the analysis, it was just checking which one it was very similar to. And one day I was sitting there, and I got the task of updating the databases, because we started noticing, or actually we didn't have any model drift or anything performance monitoring at all. It was just basically someday a researcher just emails and says I had this bacteria, but I didn't get a result on this gene. And then we were like, oh, of course it wasn't in the old database. It's been updated and we haven't done that. So that's basically how we just knew when to update the database, which was actually not a very good, it's not a very good system. And one of these days I'm sitting there, and I see that the folders are starting to disappear. When you're in the viewfinder on your computer, and it starts disappearing one by one. And my colleague is sitting behind me, and I'm just are you guys also seeing this, or is it just me? And they were no, we're also seeing this. And I was okay. And then at some point, it was all gone. It was just an empty, the whole intranet of the whole agency just gone. All the folders that were arranged by department and stuff. Yep. And I was I was what do we do now? And they were and we waited. And then maybe 30 minutes later or something, there came an email, and it was the IT, and they were yeah, so we've been ransomwared. Someone has clicked a link. I know who actually clicked this link, but I'm not going to out him, but I know he was definitely shamed that day. But we have managed to stop it, and we have reversed it, and we have reversed it. I mean, they took the backup and just spun it all up. And they actually managed it quite well. But because we were shadow IT, it meant we weren't really backed up. And I called them and I said okay, please tell me that you have backed up our stuff, because that was the only thing they actually did. And he's yeah, it's backed up, but it's a year old. And I was oh no. And so everything I had updated was gone. And we didn't really have any documentation of actually what I had updated at the time. So I was just I just have to redo everything. And so that was one of the things I was and then I told them, could you please back up our stuff? And they were how often do you want it? I'm I don't know, maybe every 3 months, just not a year. So it was also because I was a data scientist, I didn't know what is good practice for storage backup. No. I have no idea. They were how often do you want it? I'm just make it more often than a year, please.
Otherwise we're going to lose stuff. That's for sure.
Otherwise I have to keep working overtime when this shit happens.
Yeah.
But I think that's interesting because, as you say, I'm a data scientist. I don't know anything about best practices and backup. And also I think some of the sessions was about that. There was Ekstrablad was telling about clean code, some kind of standard discipline in terms of writing code. So when you transfer your project or you need to go in and do corrections, you can spend your time actually doing something instead of struggling just to read the code because of bad naming and I also noticed in terms of NVIDIA presenting some of these pre-produced tools, you can do some framework to and then you have a community that is very open source minded and explorative and curious and you go, but it's also an area where you need some kind of it's unexplored, and you need some kind of mutual understanding of where you're going, and to get that sort of consensus across the full company on what are we actually doing, and that's cross silos and verticals and horizontals, and that was also some themes that came up when Maersk presented and DSV, some of these, how do we do a project like this internally in the organization.
Yeah, and how
not only doing it, but also when people leave or we transfer it or we need to do corrections or the retrain.
Yeah, the whole implementation, documentation, change management. Yeah. There's a lot of new things in regards to. It's not just go to a app store or something.com to start using AI. There's a lot of mechanicals behind it to implement it to an organization. So there's the people and tools, documentations, what to do, what not to do. Your theme in the presentation was chasing the unicorn.
Yeah, exactly. So the idea was that, and I mean, the good thing about so when it comes to the application development or like the development of machine learning and AI, so it's been used in like kind of like two ways, if I can generalize it. So you had like the way I was using it, which is a way a lot of data scientists may use it, which is like you develop once and then you do the inference, or like you make it do what you trained it to do, maybe on a data set or whatever, and then you publish the result because you're in academia and you publish the result in a journal, and then that's it. So then you're really good at collecting the data, doing the exploratory data analysis, and doing the model development, but and usually it's had stopped there. Mm-hmm. But when you're looking at actually the more production development or production implementation, then it doesn't stop there, because after you've developed the model and it's quotation mark finished, then you have to decide, okay, but where do I put it? Where it's supposed to run? And in what format do we want it? Is it supposed to be in a finished program? Is it supposed to be in a web page? Should it just run in the background? How does it present the result to someone else? Should it make a decision based on what results it gets? So to talk about machine learning and AI is also to talk about automation. And when you're going into that area, how to say, the more front end of things, usually that's, at least for me and a lot of other data scientists I know, we're not software developers in that sense. We don't know how to maybe write web page code or any other things like that. And maybe also that's not what we're getting paid for, or we don't have time to do it. And these are issues or problems that the DevOps community have had and solved a long time ago. They have a lot of these really nice platforms of how to do the applications, and also like best practices, like how do you document your code, how should you write the code, and everything like that. So it has been more just that the machine learning and AI is just like, it's just a little engine. It's just like an extra function within these applications, more or less. They could be very simple, they can be super complex, and everything in between. But the basis was that, okay, but I'm really good at programming these mathematical models and generating a finished result, but everything that comes afterwards I have no knowledge about, because I just know how to use it and work with it inside my programming language, the IDE, and then moving it somewhere else and putting it into production. That was unknown territory for me. So I had to do a lot of that manually and try to figure out. And of course it failed a lot of times on the way. And now they're like finished, developed solution tools that you could buy. And I would definitely recommend doing that, just because you will save so much time and frustration. For sure. Yeah, I totally agree. It's understanding of course, the business, the people behind it, the tools already existing, as you mentioned. Should it run in cloud? Should it run on-prem? What tools can be provided? What hardware is the optimal to use it for? Is it a combination? Stuff like that. So there's a lot of prerequisites, checkboxes that you need to mark before just banging away the AI and ML, because it's such a big wave now. You told the story before we started recording at the hotel this morning in general knowledge in public. Yeah. Okay. So what I said was that if I compare like the general public today compared to like maybe 2 or 3 years ago, everybody's talking about AI a lot more. I would say maybe even some people are like sick of hearing about AI. But just this morning at the hotel, I was eating breakfast, and I think they were Americans, and I could hear them talking about AI. And I kind of noticed from the discussion, they're not data scientists. But if I had been in a hotel for a conference 2 or 3 years ago, and I would have heard someone at the table next to me talk about AI, I would be like, oh, fellow data scientists, how do you do? But now everybody's talking about it.
Yeah.
So the general public and their knowledge has definitely increased. And with it also, a lot of universities have developed a lot of tools to accommodate the general public. So a lot of knowledge and the maths and the principles of AI are now really publicly available and well written. So you don't have to be a mathematician to understand the principles of what we're doing. And that didn't exist either a couple of years ago.
No.
So one of the tools I like to talk about and mention is the NVIDIA container registry. So NVIDIA, to begin with, has a really nice enterprise suite called NVIDIA AI Enterprise. And what it's about it's a software stack that you can apply on, preferably maybe like a DGX and other GPUs that you would use, but NVIDIA, of course. And it provides you with the drivers to utilize the GPUs perfectly. And it has two purposes. So the one is for the IT and management, right? So the NVIDIA AI Enterprise also handles the interface for you as IT to manage and monitor the hardware itself. Like, how is the environment doing? How is it feeling? And the other part is for the data scientists. So within this AI Enterprise, I get access to the workstation or my workspace. I have a model registry, which means it's a place where I can actually upload my finished models. And within it, you also have the model versioning. So if you are retraining a model or development, you can actually see which version is which. What metrics did it have when you ran it? And you can also give cloud access to different model registries within it. So let's say that you are a data scientist company and you produce applications by demand. You could actually host those models in private registries, which you give access then to your customers if they wanted it, or even if they want it as a container or something else. And it also includes like model cards and documentation. And just having that makes everything much easier because it also makes it more transparent. So even if you as a customer, like, I ordered this model, so maybe they just hired you to develop the model and not the software itself, then their software developers can just go in there and be like, okay, which model was it? It's this one. Okay, what have they done? Okay, they've done this. And it just makes everything much faster and flexible. And yeah.
Yeah, and also from what I understand is like NVIDIA is taking care of the optimizations towards the hardware. So whenever you have, because it's a fast moving industry, so when you have changes in refreshes and new technology on the hardware side, you sort of leave that to NVIDIA to secure that you're using the hardware in an optimized way, so you can, as a developer, can focus on what you're good at and what you're actually supposed to do, instead of missing out on the optimization of the hardware.
Yeah, for sure. And it might almost sound like I'm working at NVIDIA, but I think it's like, I think what people sometimes may forget or maybe not know is that even though a lot of the focus on NVIDIA has always been their GPUs, their hardware, they do have world-class computational GPUs. And I think like even now, if you buy the Hopper cards, they actually include the NVIDIA AI Enterprise within it because it is such a good tool to use. But if we look past the hardware, actually, I haven't really focused anything on like the consumer GPUs. It's more about the data center and maybe the rendering and VDIs. They are actually a huge software company, and people I don't think realize that because a lot of the focus is on the GPUs and the GGXs or the superpods or even the switches nowadays. But they are putting a lot of effort into software development and also algorithm development, right? So they have a huge development team who actually work with developing algorithms and then releasing them pre-trained or even fine-tunable in this container registry. And it's actually open and free. So even as I have this NVIDIA Enterprise and I go in, or maybe I even get a case where someone is like, okay, I want you to build this. I can actually look at the container registry to begin with and see, okay, have they done something similar? Can I just pull this down already finished and apply it? And I think that's one of the really, really cool things. It's called we usually call it a model zoo when we're looking for the models. You have the model registry and then you have like free model zoos where you can just try to find something that's already been pre-built. And that's I love it.
Yeah. And you also mentioned the NGC catalog.
Yes.
In this case as well, there's a lot of pretty cool stuff that you can just go find and deploy.
And some of the things you don't even have to log in to use. You can just like Google right now and go to NGC and have a look. Yeah. You can just download the models right now. It's really cool.
Exactly. And that's the good thing about Aero. We can actually do, as we mentioned before, everything from the microcontroller unit or whatever it be, and add our components to embedded solutions and NVIDIA or public cloud or servers. So depending on the underlying infrastructure, or if it should run in a cloud with an abstraction layer or whatever it is, we can guide the listeners all the way.
Yes.
In the AI ML landscape.
Yeah, and I think what like Aero is good at, or has always been good at, is data center components. And I think sometimes people might forget that, like when we talk about AI, we are talking about a whole data center, because it's not enough to just get the GPU, and you need everything else to accommodate it, because actually when we're doing machine learning or AI or application development, we are actually at the top of the stack, and we need the rest of the stack to even run it.
Yeah.
And that's why it's really good to actually talk about it, because sometimes you can get like requests where they're like, okay, I think it's going very slow, we need to get another GPU. And then when you start talking about them, like, okay, but why do you need another GPU? You find out that actually GPU is not the problem, it's the network, or the storage is too slow. Yeah. So just trying to find those bottlenecks as well. So that's why it's really good to go to a data center company, because we do have the whole picture of this. Yeah. Sometimes it's not as easy as just throwing a piece of hardware at the problem.
Exactly.
Ethics was also a subject. Is it something we should comment on, or is it going out of scope to discuss?
No, I don't think it's out of scope. So the AI ethics, for people who don't know what that is basically just like, it's kind of just like GDPR for AI. They call it ethics, but for me, it is definitely more about, it's like AI governance, I would call it. I wouldn't, because it's not as much as about ethics, it's rather about, like, do you have documentation of everything you've done when you have developed this? Do you have documentation about how this data was collected, how the data processing has been? Are all the groups fairly represented? Is it transparent? Can you trace everything? Can you protect this model? Can you protect this data? Is it secure? It doesn't invade anyone else's privacy. And when you have it in production, it's also about you have to supervise, or for model drift to see, is it still as good as the day you made it, or is it getting worse? Can you retrain it to keep so it's also like a quality insurance of the application that you have developed. And I mentioned the NVIDIA AI Enterprise before, but it also has it covers a lot of this topic, because what it means in practice is that you have to have documentation, versioning, transparency, but you just have to document all the steps on the way. And this has been talking a lot because of the AI Act that is landing soon. There are already also tools out there that will collect all this information automatically when you are developing algorithms and models, and the metadata of the development of everything, and store it and document it, and you can have it in a nice collected place. So if you have to revisit something, or worse, something bad happens and you have to go back and look at the documentation, or you get inspected, you could just easily pull this up, and you can see why the decisions were made, how the data was handled, and also why the model makes the decision it makes. So before, it's always been talking about this AI is like a black box, nobody knows what it's doing. It was kind of true to a certain point. So, and now it's not enough. So let's say you have a model and it makes a decision not to grant someone a loan based on certain variables. And this person is like, yeah, but I want to know why this algorithm didn't give me this loan. And then you actually would have to pull out this data and say, yes, this model decided the probability for you, or the risk was very high because of blah, 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 blah. You have to be able to prove that. You cannot say, I don't know. We trained it and blah, blah, blah. It won't work anymore. And when you think about it, it kind of makes sense, right? Because if you would go to the bank and they wouldn't give you a loan, you would be like, why not? That would be the first question you ask.
Yeah,
so,
then the banker wouldn't tell you, I don't know, or I can't explain. That doesn't make any sense.
Yeah,
because,
and would you trust that guy? And if you would sit in front of the banker and he'd be like, no, I don't know why I can't give you. Would you recommend that bank to someone else?
Absolutely not.
No, exactly. But I think that also brings in, as you say, it's because it's again a hybrid approach, right? And look on where is your data stored, how is it processed, and so it's not just an algorithm; it's the whole package around building a project.
Absolutely.
Yeah.
There's a lot of moving parts in this, and that the listeners and the business and the technical team and the business team should be definitely aware of, and we have the knowledge to guide them through the whole journey, landscape, or implementing, etc. on especially with you and the rest of the technical guys we have in Aero, and the knowledge that we have around the Microsoft, the AWS, the Lenovo, the Nvidia, etc. So we have insights on when and where and how to do it, and has it been done right.
Yeah, and usually we also like this kind of project because it's fun, because suddenly it's more teamworky than just being like, okay, I need a storage solution. Who is the storage guy? But then it's like, okay, they need an AI solution. Okay, so let's bring in the network guy. We'll bring in the storage guy. We'll bring in the compute guy. We'll bring in Sara maybe because she's a software girl. And then we'll bring in the and then we have to think about and work together for what is a really nice solution.
Yeah.
And then also, especially if people do have sometimes demands of sometimes people will come in and say, yeah, we're open for things, but they might have a brand that they we have to have this or we have to have that. And then we have to work around, okay, they say they have to have it. Does it work? Yes or no? If it doesn't, okay, we have to tell them why. If it does, okay, sweet, we'll be in there and then work around.
Yeah, we'll make it fit. Yeah.
Yes.
So everyone listening out there, thank you for attending this podcast and listening to all the inputs. If you want to know more about how Aero can assist you in the AI ML journey, path, landscape of complexity, well, please contact one of us that is in the description, or your local Aero contact person. Thank you, Sara, for attending. Thank you, Sara, for attending. And
thank you.
To the listeners out there, thank you for listening.
Cool. Bye.
Bye-bye.
Bye-bye.
Husk, du kan finde links og mere materiale i podcastens episodebeskrivelse. Tak fordi du lyttede med. Ha' en skøn dag. Har du ønsker til en podcast, vi endnu ikke har lavet? Så send os en besked.